So today we're going to be looking at the topic of simultaneous equations. So a simultaneous equation is needed when you have two variables in an equation. So hence you need two equations to work out the two variables. And those variables are usually in the form of x and y, but they can really be in any form, a, b, z, x. It doesn't really matter. They just represent numbers. They're just variables. Okay. So there are two ways in which to solve a simultaneous equation. The first method is called the substitution method, and that's the first method that we're going to look at today. So the main idea with the substitution method is to ensure that for one of your equations, either equation 1 or 2, your variable, which can be x or y, is the subject of that equation. So we'll look at the first example. All right, so this is our first example here. So the first thing I'm going to do is rewrite these equations and label equation 1 and equation 2. So first we have y equals 2x, and I'm going to call that equation 1. We have 3x plus 2y equals 14. And we're going to call this equation 2. So in the beginning we said that we need to ensure that for one of our equations, our variable or one of the variables is the subject of that equation. And if it isn't, then we need to make it the subject. So in this case, we have our two equations over here, and we can see that in equation 1, y is the subject of the equation. And hence, we don't need to make it the subject because it is already the subject. So what we have to do now is simply substitute this equation into equation 2. So we're going to write sub 1 into 2. So what this means is that wherever you see the letter y in equation 2, you substitute in 2x. So we're going to do it as follows. So we start with 3x plus 2, and then this is multiplied by our y, and our value of y is 2x. So we put a bracket, we put 2x, and we continue the equation, equals 14. And now that we have reduced this to only one variable, our variable of x, we can simply solve this like a normal equation. So we continue simplifying this equation. So 2 times 2x is 4x, and that equals 14. And then we have our like terms, so 3x plus 4x is 7x, and that equals 14. And then we divide both sides by 7 to make x the subject, and we get x equals 2. So now that we have solved the value of x, we now need to find the value of y. So in order to do that, we go back to our initial equations up here, so equation 1 and 2, and we're going to choose equation 1 to find the value of y, simply because it is in the simplest form. So the next thing we do is we sub x equals 2 into 1. And if you recall, our equation 1 is y equals 2x. So when we sub this value of 2 into this equation, we get y equals 2 times 2, which is 4. So therefore, we can conclude that x equals 2 and y equals 4. So now that we've solved the value of both variables. So we're going to look at another example. Okay, so we're going to look at this next example, and we're going to use the same substitution method. So the first step is to rewrite both equations and label equation 1 and equation 2. So we're going to start with the first one. So 2x plus y equals 10. And we're going to call that equation 1. And our next equation is 7x plus 8y equals 53. and we'll call that equation 2. So if you recall, the substitution method enables us or requires us to ensure that one of the variables, either x or y, is the subject of one of the equations. So if you look back to our equations, we see that equation 1 is the easiest equation to manipulate to form y as the subject of the equation. We could have done the same with equation 2, but that would require more steps. So what we're going to do is we're going to change equation 1 to make y the subject of that equation. So we're going to rearrange 1. So what that means is we initially have 2x plus y equals 10. And our aim is to make y the subject. So we're going to move this 2x over to the right-hand side. So we get y equals 10 minus 2x. And because we've changed this equation, it's no longer called equation 1, but rather equation 3. So we now call this equation 3. I'm just going to split the page in half, draw a line down the middle. There we go. Okay, so we're going to continue up over here. So now what we do, now that we have y as the subject of this equation, we can substitute this value over here into our second equation. So we say sub equation 3 into 2. So what that means is that rewriting equation 2, but instead of writing the y, we're going to replace that value with the value of 10 minus 2x, which we got from equation 1. So now we have 7x plus 8 lots of y, and y is 10 minus 2x equals 53. And now that we've reduced it down to one variable, we can solve this like a normal equation. So what that means is we need to simplify this bracket. So we have 7x plus, so we multiply 8 with 10, we get 80. And we multiply 8 with negative 2x, we get negative 16x. And that equals 53. So we have like terms of 7x minus 16x. So what we're left with is minus 9x. And we're going to move this plus 80 to the other side. So what we're left with is 53 minus 80, which is minus 27. Now we simply divide both sides by negative 9. And we get x equals 3. So now that we have a value of x, we can now find the value of y. So could you please repeat that step? Sure, no problem. So what we're going to do is we're going to take it back to this step over here. So what we did was we rearranged equation 1 to make y the subject, because that's what the substitution method requires of us. So once we make y the subject of the equation, we can now substitute this value over here into the value of y into equation 2. So we're going to sub this part here. So we're going to sub 3 into equation 2. So now what we're going to be left with is 7x plus 8 lots of y. And y has a value of now 10 minus 2x. So we're going to replace that y value with this. So we have 10 minus 2x. And that equals 53. And now that we've reduced it down to one variable, we can work through this like a normal equation, because that's our aim. So now we simplify. So we need to simplify these brackets, and by simplifying, we multiply. So we multiply the 8 with the 10, and the 8 with the negative 2x. So 8 times 10 is 80. And 8 times negative 2x is negative 16x. And that gives us 53. Now it's just a matter of collecting like terms. So 7x minus 16x is negative 9x. And we're going to move this 80 over to the other side. So we have 53 minus 80. And we're going to collect these like terms again. And 53 minus 80 is negative 27. And to make x a subject, we divide both sides by negative 9. So what we're left with is x equals 3. So now that we've found the value of x, we can use that value of x to find the value of y. So what we do next is we substitute this value of x back into this equation 3, because y is the subject of this equation and y is what we want to find. So we sub x equals 3 into 3. So now we have y equals 10 minus 2, lots of x, and x is 3. So that gives us 10 minus 6, which gives us 4. So therefore, we can conclude that x equals 3 and y equals 4. So we solved both of these equations using the substitution method. But there's another method to solve simultaneous equations, and that method is called the elimination method. So with the elimination method, you want to essentially eliminate a variable because you have two variables and you want to eliminate one of them to find the first one. So in order to do that, you need to ensure that the variable that you want to eliminate, say x or y, has to have the same coefficient. So the coefficient is the number in front of the variable. So they have to have the same coefficient in both equations. And what that means is that once they have the same coefficient, you can eliminate them out of the equation. So what we're going to do is we're going to look at our first example over here. So we're going to follow through with the same first step, and that first step is to rewrite both equations and label each equation 1 and 2. So we're going to write this first one, so 2x plus y equals 1, and we're going to call that equation 1. And then we have x minus y equals negative 4, and we're going to call that equation 2. Okay, so what you have to determine is you need to ensure that the same coefficient occurs in front of the variable that you want to eliminate. So what we're going to first look at is our variable of x. So in our first equation, x has a coefficient of 2. And in the next equation, x has a coefficient of 1. So they are not the same coefficients. So then we consider y. So in equation 1, y has a coefficient of 1, and in equation 2, y has a coefficient of negative 1. So in this case, they have not exactly the same coefficient, but the same value, and that's what we're after. They both have a value of 1, even though they're opposites. But as long as they have the same value, then we can eliminate them. So in order to eliminate positive 1 and negative 1, we simply need to add them together. And so that's what we're going to do to both equations. We're going to do equation 1 plus equation 2. So what that means is that we first consider our values of x. So we have 2x in equation 1 plus 1x in equation 2. So 2 plus 1 is 3. So we have 3x. Then we consider our y's. So we have y minus y is 0. Equals 1 plus minus 4, which is negative 3. Now that we've eliminated the value of y, we can simply solve this like a normal equation. So we want to make x the subject of this equation. So we have 3x equals negative 3. We divide both sides by 3, and what remains is x equals negative 1. Now that we've determined the value of x, we can determine the value of y. So what we do is we're going to substitute this value of x back into equation 1. Or you could substitute this value of x into equation 2. It is up to you essentially, but I'm going to substitute it into equation 1. So sub x equals -1 into equation 1. So what remains is 2 lots of x. So we have 2 lots of -1 plus y equals 1. So we simplify that, we get -2 plus y equals 1. And we move the -2 over to the other side. So what we're left with is y equals 1 plus 2. 1 plus 2 is 3. So therefore, we now have both variables. So therefore, x equals -1 and y equals 3. So we're going to explore one more example. And in this example, neither of the variables have the same coefficient or the same valued coefficient. So what we're going to have to do is manipulate the question. All right, so looking at this next example, we're going to solve it using the elimination method. So our first step is always the same thing, and that's writing each equation and labeling the equation. So 15x plus 2y equals 27. We're going to call that equation 1. And 3x plus 7y equals 45. We're going to call that equation 2. So if you recall, when using the elimination method, you need to ensure that the variable that you want to eliminate, whether it be x or y, have to have the same valued coefficient. So we consider our x's. So the coefficient of x in our equation 1 is 15, and the coefficient of x in equation 2 is 3. They are not the same. So then we consider the variable of y. So the coefficient of y in the first equation is 2, and the coefficient of y in the second equation is 7. So neither the coefficients of y are the same. So what this requires us to do is manipulate one of these equations to form an equation in which the coefficient of a variable is the same. So when looking at the coefficients of both variables, the easiest one to manipulate is the coefficient of x. So what that requires us to do is multiply equation 2 by a certain constant so that we get the same coefficient as it has in equation 1. So in equation 1, x has a coefficient of 15. And in equation 2, it has a coefficient of 3. So what is a constant that we can multiply 3 by in order to obtain 15? So what do you think? What constant must we multiply it by in order to get coefficient of 15? So 3 times what gives us 15? So you can fill that out right there using your mouse. Excellent, 5. So if we multiply this 3x by a factor of 5, then we get 15x, and that's what we want. We want to achieve a coefficient of 15. So we're going to do as follows. We're going to multiply this equation. Now, in order to obtain a coefficient of 15x, we multiply by 5, yes. But what that means is we have to multiply every single term in the equation by the same constant in order to ensure that we don't change the question. So what we have to do is we have to multiply equation 2 by the factor of 5. And we're going to multiply each term by that factor of 5. So what we end up with is 5 times 3x, we said was 15x. 5 times 7 is 35. We have 5 times 45, which is 225. And we're going to call this new equation, equation 3. So now, when we look at equation 1 and equation 3, we see that they have the same coefficient in front of x. So there's a positive 15 here and a positive 15 here. So in order to eliminate 15x and 15x, what order of operation do we need? Do we need addition? Do we need subtraction? Do we need multiplication or division? What do you think? We need subtraction. Good. So What that means is we're going to subtract equation 3 from equation 1. So we're going to do 3 minus 1. So 15x minus 15x is 0, which is what we want. Then we have 35y minus 25y is going to give us 33y. And then we have 225 minus 27, which gives us 198. I'm just going to split this page up and we'll move on to here. Alrighty, almost there. So in order to make y the subject of this equation, I'll just rewrite that here. We need to divide both sides by 33. So what we obtain is y equals 6. So now that we have the value of y, we can use this to find the value of x. So what we do now is we go back and I'm going to substitute this value of y into equation 2 because equation 2 hasn't been used yet. So we sub y equals 6 into 2. And that's going to enable us to find the value of x. So I'm going to rewrite equation 2. So 3x plus 7y equals 45. So we're going to substitute the value of 6 into y. So we have 3x plus 7 lots of y, and y is 6, equals 45. And then we have 3x plus 7 times 6 is 42, equals 45. We're going to subtract 42 from both sides. So we have 3x equals 3. And then we simply divide both sides by 3 to find the value of x. So we have x equals 1. So now we can conclude that the value of x equals 1 and y equals 6. And there you have it, the value of x and y using the method of elimination. And previously you found the value of x and y using the substitution method. So just as a quick recap, the substitution method and the elimination method are both methods to help us find the values of x and y. The substitution method allows you to substitute one variable into the other. So what that means is that one of your equations has to have the variable as one of their subjects. So in this we saw that equation 1 has subject of y. So on the other hand, when using the elimination method, we're eliminating a certain variable. So in order to eliminate a variable, we need to ensure that the variable that we want to eliminate, be it x or y, have to have the same coefficient, or rather the value of that coefficient has to be the same in order for us to eliminate. So we can eliminate them by adding them together or subtracting the equations. And there we have it. That's how you solve simultaneous equations using either the elimination or the substitution method. Did you have any questions? Alrighty.